In a specialized building like this, NASA built a new machine for science. The James Webb Space Telescope is a complex collection of scientific instruments designed to tackle some of the biggest questions in astrophysics. Webb has 4 instruments contained within the Integrated Science Instrument Module, or AIMM, located directly behind the primary mirror. They are all designed to observe an infrared light, which is invisible to human eyes. Infrared is a longer wavelength of light located on the electromagnetic spectrum, just beyond light human eyes can see. We feel infrared light as heat. Each of the instruments play a different scientific role. The near-infrared camera, or NIRCam, is the main imaging system. NIRCam will look back in time to study the formation of the earliest stars and galaxies. One aspect of its design includes the ability to block light from a bright object, so much that a much dimmer object nearby might be observed. This means that in addition to looking at distant objects from the earliest days of the universe, scientists hope to study aspects of planets orbiting nearby stars. The NIRCam instrument also plays a key role in the process of aligning Webb's 18 primary mirrors, its secondary mirror, and its fine steering mirror using a clever technique called wavefront sensing and control. One of the best ways to find out new information about distant objects is through analysis of the light those objects emit. The Near-Infrared Spectrograph, or NIRSpec, will collect spectral information about distant objects in order to determine their composition, temperature, velocities, and mass. To do this, NIRSpec will employ a unique technology called a micro-shutter array. It's an extraordinary collection of mechanical shutters, each barely wider than the thickness of a human hair, that can simultaneously collect high-resolution data from up to 100 distant objects. Different wavelengths of light present different information, and each of Webb's scientific instruments pursues different slices within the infrared spectrum. The mid-infrared instrument, or MIRI, will look at wavelengths of light that are a little longer than the other instruments will observe. Not only will this enable extraordinary images, but it will also allow scientists to search for planets around distant stars, dust warmed by starlight in protoplanetary disks, and comets and asteroids in our own solar neighborhood. MIRI is the coldest instrument on Webb, operating at just 6 degrees Celsius or 11 degrees Fahrenheit above absolute zero. The fourth part of Webb's instrument suite is 2 instruments. The Near-Infrared Imager and Slitless Spectrograph, working in concert with the Fine Guidance Sensor, will look for ancient light in the universe and information about planets around distant stars. The Fine Guidance Sensor helps keep Webb pointed and perfectly steady during all observations. Together, these instruments and the technologies that will enable them will make up one of the most complex and ambitious undertakings in the history of humanity. This is NASA's James Webb Space Telescope.